I was asked to step in for C and D of this problem. So the first thing I'm going to do is take each of these quantities and convert it into moles. So I have 1.5 times 10 to the 24 atoms of hydrogen, and I'm going to convert that into moles of hydrogen by using the relationship that there are 6.02 times 10 to the 23rd atoms in 1 mole. And when I do that arithmetic, and that's just 1.5 times 10 to the 24 divided by 6.02 times 10 to the 23rd, then I get a value of 2.49 moles of hydrogen. If you're having a problem with exponents, you're not using the exponent key. If you don't know how to use the exponent key of your calculator, put all of your scientific notation numbers in parentheses. That will tell the calculator that that is one number. So now I need to convert my 88 grams of diatomic oxygen into moles because my sulfur was already in moles. And I'm just going to leave, let's see, I have 2.49 moles of H, I have 1.0 moles of S, and I'm going to convert my 88 grams of diatomic oxygen. So 88.0 grams of diatomic oxygen, that means O2, and I'm going to convert that into moles. So 1 mole of O2 is 32.0 grams of O2. Now there are several ways to do this. I'm actually going to take this down to the element because my other items are in their elemental form as well, just the single element. So in 1 mole of O2, I have 2 moles of O. So when I do this arithmetic, and it's just 88 times 2 divided by 32, I get 5.5 moles of oxygen. So these are the values that I'm going to use now. So for C, the question is, if the mixture of the 3 elements formed a compound with molecules that contain 2 hydrogen atoms, 1 sulfur atom, and 4 oxygen atoms, which substance is consumed first? Well, if we do this mathematically, we can use these subscripts as relationships, molar relationships. So if I have 2.49 moles of hydrogen, and I will use 2 moles of hydrogen for every 1 mole of H2SO4, how many moles of H2SO4 could I make? And I'm just going to give you all of the digits that I had. It was 1.245 moles of H2SO4 were possible. If I have 1 mole of S, not O, 1 mole of S, and I need 1 mole of S for every 1 mole of H2SO4, then I can create 1 mole of H2SO4. Now I'm going to perform the same calculation with oxygen, just atomic oxygen, and there are 4 moles of oxygen for every 1 mole of H2SO4. And I get these molar relationships right here. I get them from the subscripts. That's what I'm using. Now remember, the lack of a number here is a 1, not a 0. That's a common mistake I see students make. It is a 1. So when I perform this calculation, I get 1.375 moles of oxygen. So the amount of the substance that is consumed first is sulfur, and it produces the least amount of sulfuric acid. So that dovetails us into D. How many atoms of each remaining element would remain unreacted in the change described in C? Well, in order to form exactly 1 mole of H2SO4, I need 2 moles of hydrogen. I have 2.49, so 2.49 minus 2. I have an excess of 0.49 moles of hydrogen, but that's not the answer to the question. It asks how many atoms. So I will convert those atoms of hydrogen, or those moles of hydrogen, into atoms of hydrogen using Avogadro's number. And I get 2.95 times 10 to the 23rd atoms of H. And for sulfur is used completely. And then for oxygen, we need 4 moles of oxygen in order to make exactly 1 mole of sulfuric acid. So I take the original amount, which was 5.5 moles of oxygen, and I subtract 4 moles, exactly 4 moles, and I get 1.5 moles of oxygen left. I convert that 1.5 moles of oxygen into atoms by using the Avogadro's relationship used above, 1 mole of oxygen, and I get a value of 9.03 times 10 to the 23rd atoms of oxygen left. Now make sure these values make sense. We had more than 1 mole of oxygen, so our number should be greater than Avogadro's number. But with hydrogen, we had less than 1 mole, so we should have less than 1 mole left. Hope that helps.